We left off with wave refraction and wave reflection. One of the last type of waves we're going to talk about in this chapter is a standing wave. All the other waves we've talked about so far were progressive, meaning that they were energy that moves from its origin somewhere off into the distance. The standing wave, that doesn't happen. So how does a standing wave occur? First, you need waves with the same wavelength moving in opposite directions. Additionally, what the best way for it to occur is when the wavelength of the wave is exactly equal to the area it's enclosed in. When we get a standing wave in a bay, which is probably the most common naturally occurring oceanic standing wave, you get a seiche. And we actually have seiches around here. What happens is you end up with a wave that appears as if it's just moving up and down with a central area where it doesn't move. So I'll try to draw this right on top of this slide. I'll use red. So you have the one perfect particle, one perfect wave rather, and at one point it moves there, and there's another wave, basically the same size, coming back in the opposite direction. We'll pretend that that is exactly the same, and there's an area in the middle, right in here, where there's no movement. So depending on which wave you are, you're either the crest or the trough, and then the trough and the crest. So you get an area of no movement, which we call the node. That's right here, or right here. And then you get the area of maximum movement, which is one for each part of the wave. There's a video that I put on the website that's actually pretty good at explaining this. It's kind of long, but I suggest you take a look at it. It shows how they generated a standing wave, a series of standing waves rather, in a wave tank. If you're going to talk about waves, you need to talk about tsunami. Really, 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 please call them tsunami, not tidal waves. We're going to do tides next chapter, and tsunami are not caused by tides. They are a wave. They're a seismic sea wave, and they usually occur from earthquakes. Most of the time, it's an earthquake that causes the typical tsunami. Some of the very, very, very large tsunamis are caused by landslides. Very rarely, you get meteorite impacts, can cause some of the largest tsunamis known. We believe, based on fossil evidence, that there was actually a 3-mile-high tsunami caused by the impact at the Yucatan Peninsula several millions of years ago. So what is a tsunami like? It has a very long wavelength, greater than 200 kilometers, sometimes as much as 500 or 700 kilometers. Because of this wavelength, and remember that to be a shallow water wave, you have to be in water whose depth is less than 1/20th of your wavelength. When you're talking about the 200-kilometer range, and the average depth of the ocean is about 4 kilometers, you can see why it is always, always, always a shallow water wave. So the wave actually moves through the whole water column. Now, people are a little confused by that. Yes, the wave moves through the whole water column, but frequently if you're on a boat, you don't even notice it, which is usually because the height in the open ocean of a tsunami is only about 5 meters. 0.5 meters. And the wavelength can be hundreds of kilometers. So compared to the natural swell, you won't even notice that. You may remember back from the beginning of the chapter that for shallow water waves, their speed are a function of their depth. And tsunami are shallow water waves, and they move very, very fast. It's not possible to outrun one, something on the order of 700 kilometers per hour. It's one of the reasons why they can be so deadly. If you ever see signs of a tsunami, you need to leave. You don't have time to wait around and see if you can see the water. This diagram is in your book, 8.21 or 8.2, I forget what number it is. And basically what they're showing here is what happens when a tsunami occurs. So we have an earthquake. Earthquake occurs here. And this half of the fault line moves up, so that it suddenly pushes up. It's like the opposite of throwing a pebble in. The water surges up, and the energy then moves in this direction. And that's basically how you get a tsunami. Now remember, when waves enter shallow water, they begin to feel the bottom. And what happens at that point? Their wavelength decreases. So even though they start out with a very small height of, say, half a meter, when you take the 200 plus kilometers of wavelength and shrink it down to a few hundred meters, you have heights of the tsunami that rear up tenfold, which is why they can be so dangerous. These pictures are actually from the tsunami that hit Thailand from the Christmas tsunami off of Sumatra. This tsunami was actually not that large. You can have tsunamis that are in the hundreds of feet. We'll talk about a very few specific mega tsunamis that can be in the thousands. But there's more than one wave. Everybody's always like a tsunami, a tidal wave. But that's not actually true. And due to the, think about ripples in the pond and the exponential relationship of the size of these waves, it's frequently the later waves that are even bigger. Again, this actually results in a lot of human loss of life because people see the wave receding and they will frequently be, oh, it's over, and not realize that was just the beginning. Tsunamis happen fairly often. Usually they're small. You get multiple tsunamis a year, one large one every 2 to 3 years, assuming plate tectonic activity stays the same. Most occur in the Pacific Ocean because of the Ring of Fire, which is basically the boundary of the Pacific Plate, which has a lot of volcanic activity and earthquake activity as well, which means that convergent plate boundaries, the areas where two plates come together, are more likely to form tsunami. Lucky for us here, we live on the East Coast where we do not have a convergent plate boundary. These are some of the major historical tsunami, and these ones are all marine. So Krakatoa, it basically blew half the island apart. It was pretty large, in the hundreds of feet. One of the largest ones in terms of damage it was actually in Alaska and then hit Hawaii. Now those are thousands of miles apart, but when it hit Hawaii, it was still over 50 feet tall, and it killed 159 people. Later on, we're going to talk about tsunami warning systems, and that earthquake and then subsequent tsunami is what inspired the DART system of tsunami warning system in the Pacific. There was a big one in Papua New Guinea. It was also very large, and it killed quite a bit of people, but they all pale in comparison to the one on Christmas in Sumatra in Indonesia. This was a very, very large earthquake, 9.3 magnitude. It's ginormous. And the waves were 98 feet at a minimum, but the loss of life is astounding. It was over 200,000 people, which is even the big Fukushima, Tohoku earthquake wasn't even close. Now, the largest documented earthquake-generated tsunami was 278 feet in Japan. Part of that was also due to the geography of the area, so I'm a little skeptical. The real largest earthquake ever occurred in Alaska, Lituya Bay, and it was actually 1,700 feet tall. And it happened when there was an earthquake. The earthquake did not directly generate the tsunami. Alaska is covered with snow-topped mountains and glaciers, and a glacier basically fell off the mountain, fell into the bay, and created a splash wave that basically wiped out an entire town. There were 4 or 5 eyewitnesses, people who were on boats who somehow survived, and it was really easy to go back and double check and make sure that, was it really 1,700 feet tall? But they went to the mountain, and basically from 1,700 feet below, there were no trees, no soil, no nothing. It had just been ripped away. The idea of the mega tsunami, and if you watch all those horrible fictional movies on the Sci-Fi Channel or even Discovery Channel sometimes, they will have these stories of these mega tsunami. And mega tsunami are very, very large waves, but they're typically not directly earthquake generated. They tend to be more from splash events, like things falling into the ocean, like meteorites or glaciers or large landslides. This is a visual of all of those really large ones. Unfortunately, they haven't updated it with the Tohoku or Fukushima, as the Americans like to call it, earthquake that happened in 2011. I may show some video in class tomorrow. It was a pretty amazing earthquake, but this is a nice visual if you want to look at the major earthquakes. We're going to leave off there. I'll talk about the tsunami warning system on the next video, which I'll probably post this weekend.